Word embedding. Word embedding is a powerful concept in artificial intelligence and NLP that transforms words into numerical vectors, allowing machines to understand and process human language. Imagine trying to teach a computer the subtle nuances of words and their relationships. It's a daunting task. With word embedding, however, words with similar meanings or contexts are placed together in a multidimensional space, making it easier for neural networks to recognize patterns and relationships. For example, the words king and queen might be closer together in this space than king and apple. This technique is particularly useful in natural language processing tasks such as spam detection, question answering, and many others. This tool will help us learn some interesting concepts behind word embedding. Let's explore it. Here we have a super simple example of word embedding in vector form. We have a table with 3 columns, each labeled gender, age, and royalty. These columns represent the different dimensions or attributes of the words listed in the rows. These rows list different words such as grandfather, man, woman, and so on. Each row has corresponding values in these 3 columns, providing a numerical representation for that word in terms of its gender, age, and royalty attributes. These numerical values are components of the embedding vector. In real NLP systems, the dimensions of this vector can be in the hundreds. For our simple embedding, let's analyze the 3 vector dimensions. For the gender dimension, positive values indicate femininity, while negative values indicate masculinity. For example, woman has a value of 0.77, indicating strong femininity, while man has a value of negative 0.72, indicating strong masculinity. Gender-neutral words such as monarch will have values close to 0, such as 0.07, indicating gender neutrality. For the age dimension, positive values represent older age and negative values represent youth. Grandfather has a value of 0.64, indicating older age, while infant has a value of negative 0.71, indicating very young age. For the royalty dimension, positive values indicate royal status, while negative values indicate non-royalty. Monarch has a high value of 0.88, indicating strong royal status, while child has a value of negative 0.81, indicating a lack of royal association. In essence, these vectors provide a numerical representation of the characteristics of each word. For example, queen has positive values in both gender and royalty, indicating that it's associated with femininity and royalty. On the other hand, boy has negative values on all dimensions, suggesting masculinity, youth, and non-royalty. Next, we can visualize these embedding vectors in 3D by plotting the vectors as a 3D scatter plot. In this plot, each embedding vector is represented by a blue point, with the gender, age, and royalty components on the X, Y, and Z axes. Here, the red dot is the origin, and this is the x-axis representing gender. Here is the y-axis representing age, and here is the z-axis representing royalty. By visually inspecting these words in this 3D space, we can tell if the 2 words are close to each other and in what aspects. We can rotate the graph in any direction to closely observe the words and their position. We can also zoom in or zoom out, and that's to help us have a better look at some words. Let's analyze these 2 vectors here, the infant and child vectors. So please note that they are very close to each other in terms of gender, age, and royalty. So if we have a look at the infant X or gender value, we see it is 0.06. The child vector has a value of 0.07 for this dimension, which is very close. Similarly, by comparing the y and z values, we see their closeness in this space. This covers how this tool can help us learn some interesting concepts behind word embedding. Please feel free to play with the tool by analyzing different words and their embedding dimensions using the embedding vector table and the 3D scatter plot.